Welcome back to Privacy Week, the 5th. It's also the 5th day. We're already we exceeded half of the week. The next talk is about blockchain and data. It's by Martin Birke. So there are some problems uploading the data. So currently there's no video from him available which is okay because actually we don't want pictures of us being so public. Martin is a university professor, and let's say he's working on, first we had data with us, now it's in the cloud, then we realized that may not be that great, and now we have GDPR as well, which says that you have to delete something, someone wants to delete their data, and how can you do that, and the possibility to have it. So Martin, please explain. I have no idea, and Martin will explain blockchain and how you can use data in blockchains with GDPR. Let's see. Martin, the stage is yours. Thanks. Well, I hope this actually works and I'm audible. Yeah. You're all well audible. So I'm actually not a university professor. I'm just employed at a university, but maybe I'll become a professor at some point because what isn't now can change. The title is Data in Change or on Change, so like in the blockchain, on the blockchain, whatever. But as has been already mentioned in the introduction, what was the development approximately of computers? First of all, we had like one big computer, which was incredibly expensive. Then we had a second step was, okay, here we have this huge and big and expensive computer at some central point, but multiple people can access it remotely using terminals, where you can like connect. But terminal is rather primitive, just a screen and something to enter stuff, but you can connect to the big expensive computer, and there's where all the data is and the computation is done. Next one was called a microcomputer or personal computers. So this personal computer stuff, which were small enough and affordable, so that it's just not one central computer, but anyone could buy their own computer and work on their data there. So that was not that bad. The next step again was you see we have telephone lines and we can make a network and we can connect those personal computer among each other, and again we can work together and use computing resources together, so we can again connect to a stronger computer from our personal computers which run somewhere, and that is then cloud computing, where again you have centralized services where our data is stored, and we use them remotely because it's quick, the network is quick. And then suddenly we have a pandemic, and we need those central cloud services because all of us sit at home and we sit at our personal computers and connect to the central services, and suddenly they are like system relevant, and they're like we can't go outside, we're not allowed to have contact with each other, but we have this central cloud service where all our data is, and here is some. I looked up some news. So yeah, because it's very popular, everything is doing by Microsoft Office 365. At the beginning, you're happy that these central services work, but over time, I found here you have an article from September 2020, from October 2020, from July 2020. You see that the first shock of the pandemic is overcome, but suddenly now the problems arise again. So what happens when this central cloud crashes? Where are the data and who is responsible for those, and how can you do this with data protection and security of data in the cloud? And it's still, we don't know what are the like laws surrounding this, because we don't have those yet, and how to develop those, etc. pp. So fifth step may be decentralized service, so stopping okay, we just want decentralized services. We want to have the option that we peer-to-peer data exchange. That is what we want. And in this regard, you hear blockchain again and again in these discussions, because, well, why not storing data decentralized on a blockchain? Because everyone has a copy of the blockchain.
So that was the basic idea for this talk. Let's look at this as an entry point. Should we use the blockchain in a project? It's an XKCD comic for those. It's quite famous, actually. And it's a bit more complicated one. Also from XKCD. Is the blockchain the solution to all of our problems? Yeah, there's a link. Maybe look at it when you have more time. But they say, yeah, they fixed it with something called blockchain. Yeah, whatever they did, don't touch it, burn it in the desert, bury it in the desert, wear gloves. So for many people, blockchain is a solution, but is it maybe actually a problem in itself, and should we stay away from it? So to explain it a little, what's a blockchain anyway? I brought a very small example. So this is the text from the ParivacyWeek homepage. So that the timing is fixed and blah, blah, blah. So if I take this text and just save it to a text file, that makes 529 bytes of data. So this is a block of data. And how do I now get from these data blocks, and I will have more than one, I will have several blocks of data, and how do I make those into a blockchain? For that, I will have to introduce a little bit of cryptography. Don't be scared, it's rather simple. You have to understand one small thing. There is something that's called a cryptographic hash function, and it is nothing else than when you feed it some data. So you feed it a block of data, for example, this text file, and then this hash function will return something called a fingerprint. It's a checksum. So, for example, I use the hash function SHA-1. It's a very popular one. And it was used a lot in the recent years. And I also added a small clue here. It's broken. It should not be used anymore. So it's not as secure as you might think. But as an example, you create the checksum using SHA-1. And then you get this fingerprint. So this one F432, F85, and so on. That is now your fingerprint. And that's a cryptographic hash function. So what are the properties of those hash functions? Well, it's actually rather simple. It is supposed to be impossible to reconstruct original data. So this number 1F432, you cannot calculate on that and recreate the data block. I mean, when you think about it, it would be too amazing if that were possible, because that would be just an incredible compression method. You would really save on storage. So that's not possible, at least not easily. And the other important point is it's computationally infeasible to create two fingerprints that are the same from different data. So to create a fingerprint, a data that creates the same fingerprint as one that you already have, that's practically impossible. So you could guess randomly. You can put in a lot of data and then check, is it the same fingerprint again? But for 20 bytes, that's a lot of options, a lot of possible fingerprints, so it's basically impossible. And the third interesting property is a very small one. No, if you have a very small change in your input data, the hash pretty much changes completely. So even if you have only the two words hello world as input data, and then you calculate the fingerprint, and then once again, after you change the O to an N, then you have a completely different hash. So just a 0 turned into a 1, and you get a completely different hash. So that's an avalanche property. A small property, a small change in the input data produces a huge change in the output data. So knowing that, I hope it wasn't too difficult. I can build a blockchain. So what is a blockchain? So let's start with the data block 1, and I use the hash function and I get a hash, a fingerprint. And once I have that, that's basically also data. And I can combine that with other data, so our data block 2, and I combine those and put them into the hash function together. So I am chaining together the data 2 with the hash value 1. And yeah, so our hash value 2 now depends on data block 2 and hash value 1. And I can just keep on doing that. I can add a third data block, and I can just add the hash value 2, the result of our second hashing operation, and combine those. So I will get a chain of blocks. So any block that gets added always includes a part of the previous block, so the previous hash sum. And it's always fixed in there. That means whenever I add data to our blockchain, it is a unique chaining. So it does matter if I add block 1 first and 2 second, or if I start with block 2 and then add block 1 second. So that means I can now put my data into a blockchain. And I will get a checksum about the data of all the chain. And that is what I originally wanted. I wanted to store my data in a decentralized fashion. Great. So I can now put the blockchain on several computers. I have decentralized copies of all these data blocks. And yeah, if you took care about, if you paid attention when we were talking about the hash function, you can answer what is happening if you manipulate one of these data blocks, or if the one data block is manipulated on one of the computers. Well, that means that this hash function does not work anymore. So each member who gets a copy can check, can test if this data was changed at all. So everyone has the same, and everyone has the same checksum, and everyone can compare it against each other. So if I compare it, I checked today, the Bitcoin blockchain had a size of about 308 gigabytes. So everything that ever happened with Bitcoin on Earth, you can download that history and check each connection. And everyone should get to the same result. So now the big questions. Every one of us now has a copy of the blockchain. Who is writing this blockchain in the first place? Who has the right to add to this database? So you need a procedure or a mechanism to vote or to get a result. So if I now could ask the audience, what's the result of this calculation? 2020 times 10 times 30. Yeah, 606,000. And the first person who comes up with the answer, they win the right to append a data block. So they add the block, and then everyone else gets this appendage from them. It's a very simple process, but is it a good solution? Well, basically, that is what happens with Bitcoin. So everyone who wants to add data has only a part of data, so their part of the data that they want to set. And now it's said that you have to change the data until you get a hash that is a certain number. And as we talked about before, you can never guess what the result will be, what the hash function will put out. So you will have to change your input data until you get a hash that starts with a given number of zeros. So it makes sense that the more zeros are needed at the beginning, the more difficult the calculations or the guessing becomes. So you can adjust the difficulty of this task. So the more zeros you need, the more guesses you will need to find a way to produce this hash. But at some point, someone will find it. And this person is then the winner and gets the right to add. Yeah, so this person who invested a lot of calculation time wins this right. The problem is that calculating something this random, it needs a lot of computational power. And that's also a lot of energy. So Bitcoin uses yearly around 74 terawatt hours of energy. That is pretty much the same as Austria. So Austria is somewhere around 70 terawatt hours. And so you can calculate, well, how much electronic waste and CO2 is getting created by this just to keep the infrastructure running. Just people fighting against each other for the right to add a block to the blockchain. And a small comment, this idea that you can invest computational power to solve a puzzle, that was already proposed in 97, sorry. It was supposed as a method against spam. So whenever you wanted to send an email, you would have to solve a small puzzle, and only after you solved it, you are allowed to send an email. And a spammer would have to solve a lot of those puzzles, and it wouldn't be worth it anymore. So that didn't work out, but the idea is quite old. So what happens if two nodes find the same answer at the same time, or find a correct answer at the same time? Well, it could be said that each one would be allowed to add a block, but yeah, that's not how it's handled. Actually, both can add it, but only one of the two lengthened chains will be accepted in the long term. So that also means if something was added to the blockchain, that's no guarantee that it gets actually accepted long term, because there might be two conflicted chains and only one of them will win out over time. So let's talk about this system for a moment. What if someone has more than 50% of computational power? Then statistically, they would have the option to always be the first one to calculate a correct hash and always be the one to add a new block. But it could also be that if I'm part of a small blockchain, that I could just rent cloud service and gain more than 50% of computational power of my small blockchain for a certain time. So this calculation, how expensive is it to get a lot of computational power? How much is it worth? That's always a question about the blockchain and the value of a blockchain.
So how is this connected to cryptocurrency and blockchain? Yeah, I can say I have a digital currency where I write everything in a blockchain. So when I send something to the PrivacyWeek, 50 units, and I send it from several positions, and those 150 units I sent from 3 different participants. All of them are sent to PrivacyWeek. So and at some point, all those transactions will be put into a new block, and at some point this will be added to the blockchain, and then they're on the blockchain. What has this to do with privacy? Well, if I would use those crypto transactions into the blockchain and write them there, and we've seen them, what is in the blockchain is can't be changed anymore. So all these, so it also tells me that person like Kuti sent 50 to PrivacyWeek, and Maxi did so, and Claudia did so. So this is actually visible for everyone, which can be good, but on the other hand, it's forever unchangeable, which can be a problem. So in practically, of course, you don't have like names there. That you don't see like names like James and Frank, but you just have like numbers and random looking IDs. So you just have identifiers, and one identifier transfers money to, or units to another identifier. So it's not an anonymity, but it's pseudonyms. So one pseudonym sends to another pseudonym, and a certain amount of money or units. So having a cryptocurrency saying that it means, when someone says it's totally anonymous, that is not true, because you have to think about if you have a cryptocurrency on a blockchain, what's the one problem is like double spending. So what is yeah, just usually this digital money is just binaries, and what if I spend it on one shop and on another as well by copying? So this shouldn't be possible to like double my digital income. Someone has to realize that and check that. So there must be some kind of mechanism in a cryptographic currency that transactions are visible for everyone and actually checkable by everyone, so that you can prove I spent my cryptographic currency money once, but when I recalculate that and see that there's a second transaction, that has to be invalid, because already this money has already been spent. So what does that mean? So that the system can actually work as the whole system can work, and that the money isn't always has the same amount. I see, yeah, which ID transferred money to which other ID. So I don't see exact names, but I can see this, and so I can see who did it in the sense of which ID. So what else? There are some other side effects. So if it's a distributed system, what if someone includes yeah. What if someone just ignores a certain transaction from a certain party? It's called X is a jerk problem. So what happens if this happens? So if someone like the US is ignoring everything that's coming from China, China is ignoring everything that's from the US. That is not nice and a problem. Or what else if someone is lucky and solves and solves a lot of those puzzles, and they just they have, so, and suddenly they have an advantage against the others just randomly. Suddenly they have like 5 blocks because they got lucky 5 times, but they don't tell all the others all the time. So what they can do is they can write transactions 5 blocks later, but then they wait until others did translations, let others make transitions, and then but adds his new chain, and can more or less like post-mortem kill those transactions by others. And of course, if data is on the blockchain, it lives forever. And there is a kind of like random data I have to change to solve the puzzle to have all the zeros at the beginning, what we saw in this example. So someone could now somewhere on the world illegally add data to this blockchain, like audiovisual data that is not legal. And when I calculate the blockchain and create a complete copy of the blockchain and calculate it, and that results, suddenly I possess criminal data. And if I live in a country where this is like heavily persecuted, this can be persecuted even if you didn't know, because the data, I suppose he's talking about like child exploitation images. So good. And then we have someone else that's very important in that case. So what is that? How can the GDPR get there? Because the GDPR can actually legally require that certain data from the blockchain has to be removed. So by law, I can require that this has to be removed from the blockchain. Okay, so the question is, but we actually want to recalculate this, so I can't just remove a block from the blockchain. That is from the basic design can't handle it. So how can I like circumvent that? I could just create a second level and say, okay, we create a cryptographic key for each data block, and additionally, I can for clear data to also get this key, so I can recalculate the data, but I need this key to actually get the clear data. And when I get the GDPR request to delete something, I just delete the key or forget it, and I have to prove that. So I couldn't get like the clear text data and just see the encrypted stuff. And so in that case, you could say the GDPR has been fulfilled. That is debated currently if this is a possible solution, but yeah. So, and furthermore, a blockchain. I depend on who wrote the software. So when I put my data on the blockchain and there's a request for deletion, everyone would have to use the same software and the same protocol to ensure that all those commands are executed exactly the same way. And how can I control that everyone in the same world uses the same software which does exactly the same things? And if one of the blockchain softwares has a problem and it has to be repaired, and someone else should repair it, so at least I can hope that they do, but what if they're not? So another point is smart contracts. So that's a new term. It's a contract which are coded digitally, yeah, and are put onto some data structure. So yeah, you see what he says on the slide. So it's digitally defined. If a certain condition happens, then something else happens. So let's say, for example, the condition is Trump becomes president. And then from one blockchain account, money will be sent to another blockchain account. This will be done automatically. Problem is, in general, this is something positive, because everyone sees that I made this agreement that when this happens, I will do this. But the disadvantage is, whoever can see this blockchain sees this smart contract, including security and code flaws of this smart contract. So, small example that happened recently in August of this year. It's an article about Ethereum blockchain. There was a Uniswap liquidity tokens in the worth $12,000 in the smart contract had a an error so that those tokens were like freely available, and the first one who found them and saw that there was a mistake was able to just get all those tokens themselves. And here you see the description. Well, yeah, we found there have been digital tokens worth $12,000 available. And the next thing was, okay, we know that it's a highly adversarial environment, so there are bad people on there. Okay, so yeah, actually, people look for vulnerabilities in blockchains. And they look through all these smart contracts and try to find software vulnerabilities in those smart contracts and check if you can actually weaponize those to exploits. And they're like real bots, which check those, which wait on these things in the blockchains and check if they can do it, if they can do changes quicker than others, so that you're bit quicker than others, a front runner. So you get an information, see there's a possibility, and then you make your transaction before this other one, and hope that you just can use your ID instead of someone else. They tried it to steal this $12,000 to recover them, but they failed. So, and what they learned from it is that, yeah, you see here the monsters are real, and the future is only getting scarier. So values on a blockchain and smart contracts and automatic transactions. So you have programs already which automatically look for vulnerabilities, and they say that the blockchain miners won't do it themselves, but those who add, because then those who add stuff to the blockchain could also try to exploit vulnerabilities. No, blockchain miners could also try to use this.
So all in all, we can see that this blockchain thing might be a solution for, well, we don't know. What might be good uses for blockchains? So for an anonymous distributed cryptocurrency, well, do we really want that? There's a reason why we have financial regulations. So we don't want people who don't pay taxes. We don't want to provide money for organized crime or allow them to finance drugs or wars. So there are reasons why some things are not allowed. So completely anonymous currencies might not even be ideal. And if I do know, so usually I know my partners when I do a transaction, and that means there is a certain trust. So I know who my partner is, so my partner in this transaction, and if something bad happens, if they do something to me, if they misbehave, I can sue them or I can get back at them. And yeah, so there is less need for a social trust in a way. So such a blockchain should not depend on mining. So useless calculations should not be rewarded. The motivation should be, if I behave properly, I'm not getting sued. Then the question is, well, if something is disputed, who is responsible for solving the problems in the blockchain? Some programmers who write some code that is in some repositories who can just rewrite the software when they feel like it. But what would be a good application? Well, there are applications where there is a lot of reading of data, but little writing. So there would be very few new blocks, but reading it would be read a lot. So, for example, ownership of land and having those records in a blockchain, that might be a good idea. And it is public information anyway, so why not? That could be replicated. And the question is, well, do we store data on the blockchain? Real-life observations and assets, do we want that in a blockchain? That has an equivalent in our judicial system, or maybe just completely virtual assets that don't have anything to do with real life. So looking back as a review, saving data on the blockchain is a cryptographic problem, and I have to distribute the data to all the participants. Then the problem is who may modify and add data and who is not allowed to. I have a privacy problem because all the data is public, everyone can see it. Also, all the information, I can encrypt it, but then I need a key. Everyone needs the same software. And actually want a construct of a database where the solution is not to just waste a lot of electricity and CO2 and electronic waste just to run this software. So the topic isn't as simple, it's complicated. It's probably not the solution for everything, but we will probably need more research. So one important keyword that came up in 2019 is local first software. So the idea is that we get back control about our software. So yeah, the trend is to cloud software, but actually we want software that works for us and we have the control. We want to collaborate, but we also want the control for the user. And there are a few ideas and results from their research. So Martin Kleppmann, who I just took out as an example, had some results. And yeah, it's not just about blockchain, but data structures in general that could be used to exchange data, but without needing a central cloud. So even in Austria, this is a topic. The government, in their current program, I don't know if anyone read it, it's quite a few pages. But on the sixth last page, they even have blockchain technologies, they mentioned it by name, and they wanted to create a master plan for blockchain and have a plan for blockchain technology and create a judicial framework for using it. And they wanted to use Austria's Excellence Center to further the work on blockchain. And talking about that, that's now a minute for advertisement for me. I come from this University of Applied Sciences in Pölten. So we are getting a new building. That's a nice thing there. But we are not only teaching, we also do security research. So IT security, the research about IT security to always be ahead in the topics. And in March 2020, we had a blockchain summit. That was pretty much the last event before Corona, but it also was where the Austrian Blockchain Center was opened. And it was a very nice event. I come from this Josef Rettel Center for Security Management. It's a 5-year project. And yeah, we work with these security questions. And the question how to handle data securely, what are the advantages, what are the disadvantages? And we're looking forward to a lot of results. We've only worked on this for a year now, but I will come back and talk about the results. And I thank you very much for your attention. I think I'm well in time and there is time for a Q&A. Thank you. Yeah, also thank you from my side. So Martin, as a quick question, I think blockchain might be a solution looking for a problem. Well, in parts, yes, but things as asset management in land, it might be a good usage for that. But yeah, to requote the comic, everything can be solved with blockchain. No, definitely not. So as any technology, there is advantages and disadvantages, and there's a reason why the things are as they are. Also in privacy and IT security, and we can consider how useful it really is, and that really depends on the use case. Yeah, well. Yeah, small trouble with the technology, but it's working. So I can imagine that a blockchain in a third world country where there's no well-established infrastructure with courts and a ledger for land assets is not as established, it might be a good idea, yeah. So blockchain is a big buzzword. My private opinion is that most people who talk about blockchain have no idea what they're even talking about. So if even the government is now talking about that, it's a bit weird. How can you tell if someone who talks about blockchain knows what they're talking about, if they understand it? Or if they're just using a buzzword? How would you distinguish that? Well, that's a difficult question. Well, there's two categories of people and situations when people are talking about blockchains. So on the one hand, there are the people who really work with the topic, who know that, yeah, there are advantages, but there are also disadvantages. And then there's the others who maybe are not as technical, who heard, yeah, blockchain, that solves the problems, and are not technical people, but more in advertisement. And if you had to deal with those, then there are telltale signs. Do they know what's happening, or do they just want to sell something and make money? And whatever's happening doesn't matter to them. And it's not always that easy to distinguish. Yeah, that's true. Yeah, a small adage. Gerald Blume, someone who is politically working, he said, blockchain technology is like the new Facebook, and we have to check that this time we do it in Europe. End of point. He's the Austrian finance minister. Is that true? Would you agree? Well, for some applications, it might make sense. Also for illustrative applications, using a blockchain might make sense. But talking about digital sovereignty, to come back to that, we should really look at these technologies. So we don't want to be depending on other people's clouds, and we don't want to use a central instance. And there is a lot of research, and yeah, we should definitely look into that and have research, as we are already doing. We don't have to be the first ones, but we should have our digital sovereignty. And who has the data? Can we exchange it? Can we synchronize our data? Do we have our control? So there's a question from the viewing audience. Could homomorphic encryption be used to solve the problem with bugs in encryption in smart contracts? Well, I don't know. The problem with smart contracts is that it's a program, and complex programs are always, it's difficult to predict what they are doing. There's research, very old research about that, the halting problem. So the trouble is that a smart contract might be great if it works, but if I write it and there are errors in there and mistakes are made, what happens if it's on the blockchain and there is an error in there and it's in the blockchain? So after 2 days, the system broke down because there was a mistake in the software. Writing correct program is a very old problem. And we have to be careful with that. So writing a smart contract is a difficult thing. Homomorphic encryption is usually too difficult and too much work, as far as I know. So to combine two encrypted data, so you can calculate with encrypted data, I don't know how well that works, how that is doable. So now the next buzzword, quantum computers will solve that. Well, the programming problem they will not solve. And the quantum computers, well, if you now start with a new blockchain, maybe you should not use the standard encryption because you should consider that quantum computers are coming. And those algorithms might not be usable once quantum computers are established. So when you are creating a new design and integrating that now, then you should already consider what happens in 10 to 20 years. So you don't have to then say, well, yeah, we took a bad encryption algorithm, even though we knew this would be coming, but I'm also not up to date what algorithms might be quantum computer safe or secure. Yeah, for me, that's all in a fog. I'm a social scientist and I have no idea about the quantum realm. I have a last question from my side. I have the impression that a blockchain is openly readable. Why should it be useful for data that should be secret? Well, I could have the request to make sure that data had a certain state at a certain time. So I also include a timestamp, but it is encrypted, but the data cannot be changed using a blockchain. And years later, I have to prove that I knew something or did not know something. So then I can say, yeah, here is my decryption key. Then you know what I knew back then, and I can prove I did not know that back then. Yeah, other questions from the viewers. So the blockchain can do certain things, but maybe other technology is better. Well, yeah, as mentioned, that depends on the application. So there's the hype cycle. Now it's the blockchain and everything has to be blockchain. And then in a few years, blockchain gets ignored and there's a new technology that's hyped. But then we can say, yeah, now we tried it for everything, but maybe for some applications it made sense. And maybe then we are in a phase where we come out of the hype and say, yeah, it might not be for everything, but for these two applications, it's really a good solution. So we keep using it for that. So let's come to an end.